Right, so now I'm recording. So everything from now on is going to be recorded. So what I was hoping that would be useful to you is if I go through any of the questions that you don't quite get at the moment, and we'll have a recording of how it's done so that you've got that. The other, yeah, that will do for now. So I've had one question asked. Jack asked me to look at question 2 on trig functions, which I'm happy to do. Trig functions are difficult because your calculator lies to you, and that's a problem. Obviously, you need to understand what it's doing and how to mitigate its changes. But obviously, question 2 on trig functions, I'm happy to go through that. But is there anything else that anybody would like to cover today? Before you answer that, let me just say about the exam. The exam is the 14th of January, I think, and it will either be in the sports hall at Aston or it might be online. Either way, it will be exactly the same time that you've already been told. That won't vary at all. So if it's in the sports hall, obviously show up at the sports hall, and that will be run as an exam in the normal way. If it's done online, the paper will become available on Blackboard at that time, and you'll just complete it at home in the normal way. The difference being, of course, I won't get to see what kind of calculator you've got, or indeed whether you've phoned a friend or anything. So those are the two situations that could happen, and at the moment no decision has been taken to change the way the exam is run. So at the moment, as far as we're concerned, the exam will be in the sports hall. Okay, if you have any questions, please ask them now, because this is a good time to do it, isn't it? Okay, so in terms of the maths, I've got trig functions question 2, which was one of the ones where you've got the sine waves equal to a y value. Are there any other questions that anybody would like to ask? Okay, nothing firing at me straight off the bat there. Okay, so what I'll do for now then. Okay, calculators. Yeah, I better. Right, I'm on screen, aren't I? So this is one of the calculators that's allowable. I'll give you more details at another time, but this is a Casio 85 series. So basically, if it says 85 on the top of the calculator, then that is an acceptable calculator. If it says 83 on the top of the calculator, thank you, Sarah, that is an allowable calculator. Preetpal, is that an 85 GT Plus? Yeah, okay, I thought it would be. That is allowable. If it says 85, you're okay. But I've seen some people with a 115. That is not okay. You can't use that in an exam. And if you bring one in, it'll be taken off you, I'm afraid. So, do bear that in mind. What I will do, I haven't actually done it yet, but I'll do it anyway. I will make a video on how to use the stores on my Casio, which is this one. But I'll make a video on how to use the stores on that, because one of the things that's come up, I've noticed, is that some people either put millions of decimal places when they're doing their workings, which is a massive waste of time, or they just use 2 decimal places in all the working, and then they present the answer to 2 decimal places, and that's not precise enough. Okay, so what I would say is learn how the stores work on your calculator. You've got at least 6 stores on the calculator called A, B, C, D, E and F. Or when you're writing things down, write them to 4 decimal places, because when you round up at the end, you're probably going to be okay. So do your working to at least 4 decimal places, and then present your answer to 2DP at the end. Is that okay? But I will make a video on how to use the stores on this calculator, basically Casio does it the same across all of the calculators, and I'll also show how to turn your calculator into radian mode or degree mode, or those sorts of things, because frankly turning up to an exam not understanding how your calculator works, you need your bumps feeling, I'm afraid. Right, so that having been said, let's get on and do one of the examples. Any 85 is allowed, yes, Philip, any 85. Okay, so I need to share my screen, which I do from here. Share application screen, and I want to share that screen, I think. Yep, that's it, shared. Okay, so let me just pull in. Come on, mouse, stop messing me about. Right, so what I want to do, I don't want it full screen, I want it part screen. Right, there we go. So I'm going to, oh, come on, don't mess me about. Okay, I'll just take question 2 part A, shall I? Which is 3 sine theta. No, I won't. Let's take part E, this one here, because it's got some negative values. Yeah, I'll take part C. So what we've got here, I'll try and sketch this out. No, I could leave that there, couldn't I, for now? So I'll sketch this out. So what we've got is, I'm taking part E, did I say? Yes, this one. Oops. I'm doing, let's have a pen so you can see where I am. I'm doing part E, which is this one here. There we go. That's a bit rough, isn't it? So that's the one I'm doing. Okay. So what we've got is minus 12 sine theta minus 5 cos theta equals minus 1. So what that's going to do for us, let's just quickly sketch what we're looking at. We've got a sine wave which obviously goes through the origin. We've got a cosine wave which comes through the y-axis around this point here. So we're going to get a curve that looks something like that. Okay, so that is r sine theta plus phi. Okay, and it's a bit of a slope, sorry about that. Now what we've also got is that is equal to minus 1, sorry, that's equal to 1. So wherever 1 is, and I don't know where 1 is, it's going to be something like that, isn't it? So what the question is saying is find the point at which the sinusoid, the sine wave there, intersects with that line, which is y equals 1 in this case, y equals 3 there, y equals 2 here. It's different values. So we're looking for these points of intersection, which could be, I mean, if you were a mechanical engineer, that could be the point at which your suspension on your vehicle bottoms out. If you're an electronic engineer, that could be the point at which damage is done to your ears in a a pair of headphones or a pair of earbuds or something like that. If you were a chemist, that could be the point at which your processes explode. I don't know, something like that. So you're often interested in some kind of clipping value, so that if it exceeds that value, you can take some kind of action. So what you would need to do is, once you've found r sine theta plus phi, whatever those values happen to be, and I will go through that, then what you do is you say that r sine theta plus phi brackets is equal to, in this case, 1. Okay, which therefore means that sine theta plus phi is equal to 1 over r, which means that theta plus phi is equal to the arcsine of 1 over r. That's meant to be an r. Okay, so therefore theta is equal to arcsine of 1 over r minus phi. Okay, now in some examples that will actually get you the value there. Let's not do it in black. Let's do it in red. So that will give you that value there. Okay, which the question says, I think, let's just click on it. Yeah, give you a value between 0 and 2 pi. So sometimes we work from 0 to 2 pi, sometimes we work from minus pi to plus pi, but generally speaking, you're working in a range of 2 pi. It's one of those two. So I tend to use both of them just because I don't know what you're going to need to use at a later point in your life. But if you get this value here, which is minus half a radian, let's say for the sake of argument, then to get it into 0 to 2 pi, all you've got to do is move forward one wavelength, which is 2 pi. Okay, so if this value were to be minus 0.5, you add to it 2 pi, which is 1.59, so that's going to be 2.3 something, minus that is going to be 2.8 or something like that, in which case this will become one of your answers. Okay. So you do this calculation here, and that gives you an answer there, which could be negative, and if it is, just add 2 pi to it. So that's the first value, but there's another value here. Okay, now in the baseline textbook, I've called this value here theta 1, and this also will be theta 1 because it's just that plus 2 pi. And I've called this value here theta 2. So let me show you those. If I can get that and bring that into here. Okay, so I'll just redraw this, A, because I can, and B, because you can see the point. So here we have a sine wave, so that goes through the origin. Then we have a cosine wave, so that has a maximum value on the y-axis. That's the combined wave. And the point about the combined wave is that the amplitude is the square of that plus the square of that, and then you take the square root of that. And then the phase angle is this value here. That's one of the things we're looking for. But if we were looking for this purple curve equals 1, the first value that you'd probably find is that one there. And that means you'd need to add 2 pi to it to get this value here. So that's the value on the rising curve, okay, which is the same as this value on the rising curve. But look, if I take the center line here, I've got a symmetric value, one on either side, and how you find that is like that. Okay, so I'm going to copy that, or at least I'm going to copy a bit of it, because that's the bit that I want, and I'll stick that on my board, because the value that I just calculated is this theta 1 here, but you've also got theta 2, which is the symmetric, by symmetry, it's the one on the other side of the maximum value. So do remember those two values, because you might need either of them. So let me move that away, stick that over there, and we'll now get on and do the question properly. So I'm going to clear that board, clear the canvas, and I'm going to put in the two equations, Control V. Right, I'll stick those over there for now. Right, so what I'd like you to do is to calculate. So we've got y is equal to minus 12 sine theta minus 5 cos theta. So can I give you a couple of minutes to get that into the form of r is it not equal to r sine theta plus phi. Okay, can you do that for me? So calculate r and phi is really what I'm asking, which is like question 1 in the in this tutorial.
Tom?
Yeah?
Haroon has asked if this will be on the data sheets. I've had a check, I couldn't see it. Is this sort of thing will be available, or should they learn it?
Yeah, let me check now. That's a good question.
Yeah.
I have a feeling it isn't. I have a feeling this is something you need to know. Let me get the data sheet up. I'll share the data sheet. I was planning to do that tomorrow. There we go. So let me just open that. The crib sheet. So if I bring that in, that's the crib sheet. Let's not maximize it. And it's only one-sided. Yeah, I don't think that's there. Right, we've got one page, haven't we?
Yeah.
Because I don't mind putting this on the sheet, and we've got time to do that.
Mm-hmm.
But I'd have to take something off, that's the point, because I've got a single page. I could probably squeeze it on the bottom there, couldn't I?
It could do, yeah. There's enough space.
Yeah, okay. All right. So let me do that. I'll just move that off the, yeah, because we're probably not going to use the double angles. You may as well stay there though if we've got space. Okay, so Haroon, I will put those on because they're not, those two equations aren't there. Because they're actually four equations. If I'm putting these on, I may as well put on that r is equal to the square root of you know, a squared plus b squared.
Yeah.
And that phi is equal to the arctan of the coefficient of the cos and divided by the coefficient of the sine terms. Yeah, so I need four equations on there really. Okay, yeah, let me do that and I will send that to everybody tomorrow. Okay, and the reason for sending it to you is if you are coming into the exam, you need to know what's on there and therefore what isn't on there, because obviously you need to learn that. Okay, right, let's do this tan to the -1 of 5/12. Get my calculator. It is in radians. It's always in radians. So I say shift arctan of, I'll say -5 divided by -12, but obviously the minuses are going to cancel. And that tells me in radians, so that is equal to 0.39, 0.39. That's what I'm writing. Clearly I'm going shift store A, so I've got that value stored in my calculator at a high degree of precision, but for the moment I'm just going to write 3.9. Now let's just think about what that actually means. So what we've got is we've got our y value is -5, so that's down there, -5, and our x value is -12, so that's twice the length of that, so that's probably somewhere about there, -12, isn't it? So I've got a line like that, and that's twice the length of that, so that's 2, that's 1. So this is probably, I'll do degrees because I know people prefer degrees. So that's about 30 degrees. That's obviously 180 degrees. So I'm expecting an angle of about 210 degrees roughly. Okay. Now, what has the calculator told me? It's told me 0.39, okay, which is that's roughly 24 degrees is what it's told me, which is sort of what I'm saying for the 30 here. So what it's told me is that angle there. That's the calculator. Calculator. Because it's taken -5 divided by -12 and it said that is the same as 5 divided by 12. So it's assumed that it's an angle in the first quadrant. Okay? But we know it isn't, because we know that it's -5 over -12, and that's the problem with your calculator. So the calculator has given you this angle here, but actually we need to add that to it, don't we? And you've got to see that that's how it works, because your calculator won't help you in the exam. So what I'm saying is that if you draw me a little sketch like that in the exam, even if you get it wrong, I can give you some credit for seeing or for thinking in a mathematical way. Okay, so that I can see that you're trying to work out what the correct angle is, knowing that your calculator isn't being very friendly at that particular point. Okay, do we get that? Are we happy with that? So what I'm going to do now is I'm actually going to say that I know is not the right value, because I have to add pi to that. So let me do that. Plus shift pi equals, and so I reckon that's 3.54. And just for the record, I know most of you get this right, but some of you don't look at the figure after this, because it's actually 3.536. So you have to round up. Some people don't notice that, and they would put 3.53, and baseline will mark that wrong because you've not rounded up properly. Okay, so be careful of that. Right, so we now have phi, which means that y is now can be written as, all right, we're getting some beeps. Do I need to respond to those? Y is equal to, what is it, 13 sine theta plus phi. Okay, so yes, that's not what I meant to write. Control Z, 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 Z. That's theta plus 3.54. Okay, let me say again, with the 3.54, I'm actually storing that at a much higher degree of precision on my calculator, but for what I'm presenting, I'm just writing it to 2dp. But if I were to use 3.54 in a later calculation, that would not be accurate enough. So do bear that in mind. So if you are going to write it down and not use the stores on your calculator, write this to 4dp, not 2dp. Okay? Right, so now what I'm going to do is I'm going to say that is equal to 1. Yeah, so that's equal to 1. So then we can say that sine theta plus 3.54 is equal to 1 over 13. So let's get a bit of space, move that up a bit. So I'm just going to jump to the next bit, which is theta is equal to sine to the minus 1 of 1 over 13 minus 3.54. Okay, can you calculate that and get a value for it, please?
Tom?
Yep.
Whilst everyone's working it out, would you mind answering a few questions we've had called from the chat?
Yeah, okay. I was just having a look at them.
Yeah, we got up to Philip. He said there are things we did not cover on the data sheet. Are they going to come up?
There are things we did not cover on the datasheet. Are they going to come up? Does the calc always give an answer in the first quadrant? Okay, right. So I don't know what you mean about the datasheet, Philip. We'll have to have a look at that. You know, tell me specifically the ones that you're missing. Does the calc always give you in the first quadrant? No, it doesn't. It will always give you either in this quadrant or this quadrant. That's what it does. So the calculator gives you a value between minus pi, theta less than or equal to pi. So the calculator works between plus and minus pi. So it gives you either that negative angle up to there or that positive angle up to there. So you've got to work out which one you actually need. Okay, so that's that. Okay, let's get rid of that. Come on, mouse. I don't want, oops. I don't want any of that stuff. Delete it. Okay, right. What's the rounding all about? Okay, Tim, let me tell you. Some people, because I ask for the answers to 2 decimal places, what I've noticed some people doing is, as they're doing these calculations, you see I've given this value here to 2 decimal places. So what they've done is they've written that to 2 decimal places, and then they've used that value for further calculations, for example here. And what I'm saying is that is not precise enough to give a final answer to 2dp, because you've already lost some precision by this point here. So either learn how to use the memories on your calculator and use those figures, or write these values to 4 decimal places so that when it's rounded up, the answer is correct to 2 decimal places. So you have to use more precision during your calculations than you actually present in your answer. That's what I'm saying. Okay, what else do we have? Where do you find the data sheet, Pritpal? It's a crib sheet rather than a data sheet, and I will send that to you tomorrow when I've made some adjustments to it. Okay. Right, so let's move on. I guess I better put all the values in. So arcsine of 1/13 is 0.08 I get, and that's going to be minus 3.54. So I get that to be minus So I get that to be minus 3.46. Okay, and that of course is radians. All right, everybody got that? Everybody happy with that? No problems as to where that came from? Yep, that's good. Right, now 3.4 radians is about pi. Pi is 3.15, isn't it? So that's slightly more than pi. So just quick reminder of where we're up to. We've got a curve that's doing something like that, and we've got a value of about pi. This is equal to 1, so let's say for the sake of argument it's here. So I've got a line here which is, let me do that in a different color. I've got a line here and our value is about there, so I'm going to have to add to it 2 pi, aren't I? So to get one of the values, so theta 1 is equal to theta plus 2 pi, so that is going to equal, and I've got my value, plus 2 times shift pi equals, and that's going to get me 2.82. And that's going to be this value here. Okay, but that's not the whole story. That's just one of the values. I now need to get this value here. Okay, and let me get this bit of equations, pinch that from there and put that onto here, Control V. Come on, stick that there. Okay, so that's theta 1 that I've got now. So can I give you a couple of minutes to work out theta 2? And we'll see what value theta 2 turns out to be. So theta 1 is the blue point, so that is theta 1, and then the green one is theta 2. Okay, is that what everybody gets? Which of course isn't actually much use to us, so we're going to have to add 2 pi to that. Okay, so the answer on my calculator is 5.811395047. So those values are in there, but I'm not going to present them in the answer because the answer is going to be to 2dp. So just to say again what I was saying before, is that if your answer, you're going to calculate values on the way, and you'll probably put them down to 2dp, but in your calculations you must use more than 2dp. So I'm saying if you're writing these down, use at least 4dp, but if you've got any sense, you'll use the stores on your calculator, so you can use, you know, the full precision of your calculator, and that will store these values. But at the end you quote your answers. Here we go, theta 1, and here we've got theta 2 to 2 decimal places. Okay, are we all right with that? Everybody sort of comfortable, or do I need to go over any part of that? Okay, whilst we're here, I think it might be worth having a look at question 3 of these. So find the magnitude and position of the max and the min of y is equal to that. So let's just move that slightly to one side so we can see the whole of the question. That's what I'm doing. Okay, so let's just quickly review what's going on here. So what we've got is a sine wave that's going to do something like that again, and that will be the 2 sine theta plus 6 cos theta. We're going to get a value, we'll get an r, we'll get a phi, you know, we know how to do that. But then we've got this plus 4 business going on here, haven't we? And what that means is that we've taken the curve and we've moved it up by 4. So it's going to be something like that. The whole curve has gone up. Okay, for the people doing electronics, that's a DC shift, and that value there is 4. So the blue curve is the same as the black curve, but every value has had 4 added to it, which means that your peak here and your minimum here are going to be the same as this value here and this value here, but with 4 added to them. Now, the curve is 2. Right, so what we've got is 2 sine theta plus 6 cos theta. So r is going to be the square root of 2 squared, which is 4, 6 squared is 36. Okay, so that's going to be the square root of 40. Okay, whatever that happens to be, bigger than 6 and less than 7. So the maximum value is going to be the square root of 40, because that value there is root 40, isn't it? And this value here is minus root 40. So the maximum value is going to be root 40 plus 4. So, what am I saying? Y max, yes, it's the y is equal to. So y max is equal to, I've got equal signs, is equal to the square root of 40 plus 4, and that is equal to, I suppose I better work it out, where's my squirt button? There's my squirt button. 40 equals plus 4 equals, so that's going to be 10.32. Is that what somebody said? And y min is going to equal minus the square root of 40 plus 4, and that's going to equal minus 2.32. Right, okay, everybody comfortable with the max and min value there? That's really nice and easy, isn't it? Now the next thing we have to do to answer this question properly is we've got to find what phi is. Now phi is equal to tan to the minus 1 of 6 over 2. And that is equal to 1.25 radians. Okay, now just think about a sine wave for a second. Where's the max value of a sine wave? Well, if we just take an ordinary sine wave, it looks like that, doesn't it? This value is 2 pi, this value is pi, this value is pi over 2, and this value is minus, no it isn't, this value is 3 pi over 2. And for you degree people, this is 360, this is 210, this is 180, and this is 90. Okay, so that's what they are. So the maximum value is at pi over 2. So it's asking the position of the max value and the min value. So at the theta max plus phi is equal to pi over 2. Okay, so we've got the plus phi, which means we're not talking about a sine wave, we're talking about one that has a phase shift in it, but the maximum value is when this all equals pi over 2. So theta max is equal to pi over 2 minus phi. Okay, so let's do that. I've got phi, so shift store B, so I'll put that into my memory B. So now what I'm going to do is to say shift pi divide 2 minus recall B equals, and that's 0.32 rads. Okay, so can you now calculate theta min? Let me give you a couple of seconds to do that. Theta min plus phi is equal to 3 pi over 2. So theta min is equal to 3 pi over 2 minus phi. And that is going to equal, move you up, 3 times pi divide 2, why didn't I do it times 1.5, minus recall B equals 3.46, which is exactly what Jack said, 3.46. Okay, so that, I have to say, is the easiest of these, isn't it? They look hard, but they're not, they're dead easy. So again, if you were designing either a suspension on a car, for instance, or the amount of vibration that a rocket is allowed to take, or whatever it happens to be, you would possibly have our vibration plus our constant that is added to it, and this would then give you the maximum hit that you're going to get when your spacecraft takes off or whatever it is you're doing. So A, the position, and B, the amplitude of it. Okay, any questions on that, or have we done it to death? And are there any other questions that you'd like to go over? Whilst we're here and whilst nobody's answering, let me just bring that onto the screen. I'm logged in at the moment, but alright, I'll come back to that question in a second, Philip. But okay, you know about the textbook, and if you take any of the topics in the textbook, down at the bottom there are always some examples, okay, that you can just do, and these aren't recorded or anything like that. Let's see if I can find a nice easy one. Yeah, here's a nice easy one. So we've got a 3, 4, 5 triangle. So, oh no, we haven't. But basically, if I put a value in there and it's wrong, I'll get a cross, and if I put the right value in, I'll get a tick. That's true on every of the topics in the textbook. And then resources, people keep asking me, are there any past papers anywhere? Well, the answer is of course there are, and here they are, they're under past papers, and these are past papers for 2015, 16, 17, 18 and so on. 20, yeah, I could put 20 up, there's no reason why I shouldn't do that. We produced an exam paper for 2020, so I will add that to the list probably next week. But if you go onto those, come back, 2019, okay, there's the exam paper, and if I scroll down, I don't want to scroll down there, I want to scroll down there, there are the solutions. Okay, so you can see the solutions, you can see the questions, so you've got some way of comparing these questions with the other ones. Okay, so that's all of the paper for a previous year, and you can see the kind of questions that you're likely to get. Okay, this is particularly, some of them are harder than others. You might notice some papers had questions that were specifically, this is one of them. So if you look at section B, what we're trying to do here is appeal to everybody. So this is the bioengineers, biomeds, were they? Can anybody help me on that? Sarah, do you remember who these people were? I think they were biomeds, weren't they? This is something that Amy taught.
Yeah, I think it's biomedical. Dubry.
Yeah, biometrical Dubry. That's the, I
Dubry,
forgot
that is the official term.
It's definitely a Dubry. You can tell that. Written by the Dubry brothers, obviously. So that was for them. This question 2 is for anybody. That's anybody who's going to do any kind of experimentation, significant figures and so on. And we've got chemists. That's aimed at chemists. And
Chemistry.
we've got this one aimed at Ilex, and I hope there's a mech one. Oh, there's a matrix one. Okay, so there isn't specifically a mech one. It must have fallen out with Becky or something that year. Who knows? But now the questions are not aimed at specific groups, but you see the matrix question there, for example. I'm looking for the determinant of, just working out a determinant, and then you need that to use Kramer's method to solve the solution. And see here, show that your answers are correct. That is the sanity check. That's all I'm saying there. So you calculate X, Y, and Z, bang them into that equation, and if they're the same, that's great. You can say, yes, I'm confident my answers are right. If they happened not to be the same, in an exam situation where you are not time rich, in an exam situation, if your sanity check says something's wrong, then tell me something's wrong, because that shows me that you are thinking in a mathematical way. You're checking your answers and you don't have time to check them, and we can give you credit for that. So if something goes wrong in an exam, sort of engage in a dialogue with the examiner, just so that the examiner knows that you know what you're doing and that you're not just applying these things like some kind of automaton. Okay, so that's where the exam papers are. What else have we got under here? We've got videos of all of the subjects that we're talking about. So you've got numbers, algebra, and all the rest of it. They're all on YouTube, but you can trot off and have a look at those, obviously. Revision questions, yeah, okay, so there you go. Sample B questions, sample A questions, so there's even more questions there. And then frequently asked questions, I'll add to that. Okay, that's not even live at the moment, but I'll put some frequently asked questions in as they come into me, because I'm sure they will be doing early in January somehow. I just have this feeling. Okay, so those are the resources that are online for you, and then obviously if you log in, you can get to your own progress. Let me log in fact, not as myself, but as somebody else. And I will also tell you, oops, what? That's better. So if I look at my progress, this value here is not right at the moment. I've not really looked at it in any great detail, but this person has done actually quite well, and this should be more than, 52% is half of the coursework mark. Clearly we've got several hundreds there, a 94 and a 78. This person should already be getting something in the region of I don't know, high 60s, mid to high 60s, I would have thought. Once I've got that sorted out, I will give you a spreadsheet that tells you how you can work it out, and the spreadsheet will allow you to put in your coursework marks, your presentation marks, and you will see how this value is calculated. I'll do that probably next week, maybe tomorrow, but more likely next week sometime. And then this figure in the coursework mark, I'm pointing at the screen with my finger, which you probably can't see, can you? But this figure in the coursework mark, you can check it in this spreadsheet to make sure that you've got the right values. If you were the perfect student who got 100% on all your tutorials, you got 100% on your attendance and your presentations, then this value here will be 100. And that would then translate into 30% of your overall coursework mark. And if you were the average student, so you got 50% on everything, then this value here would be 50%, and that would translate into 15% of your overall coursework mark. And if you were the worst student, so you got 0 on everything, this value here would be 0, and that would be 0 in your coursework mark. So Hashim, could I upload the latest lectures for Kramer's method? Yeah, I think that's there, isn't it? Resources, lectures, Kramer's lecture, yeah, it's there at the bottom. And there he goes, Kramer's method lecture. It looks a bit messy, doesn't it? So go 2, so that's minus, okay, there it is. You don't really want to see it. Okay, how long is the exam? 90 minutes, an hour and a half if you'd rather. So you'll be quite busy in 90 minutes. There's quite a lot to do in 90 minutes, but that's how long it is, yeah. Can I explain a bit more about the quadrants? Okay, right, listen, I think what I'm going to suggest now is I think we're not going to do anything new from now, as nobody's asking any questions. So anybody who's had enough, you can blow at this point, but anybody who wants to stick around and ask some specific questions like this about quadrants, then I will go over that again. I don't mind going over things multiple times. There's really no problem with that. But anybody who thinks they've got everything they need out of this session, feel free to go at this point. And I will now go over any specific questions that anybody wants to know. Okay, right. But what I'll do, Philip, for the quadrant is I'll set up a series of examples and get you to do the calculations, and then I'll go over them. I think that's perhaps the best way to deal with that. So you've got some practice at doing them. Okay, right. So I'll say goodbye to anybody who's going to go at this point, and I shall do some of these quadrant questions. And I'm going to invent them off the top of my head, which is always a dangerous thing to do, but we'll see. Okay. Right. So let's find y is equal to 2 sine theta plus 3 cos theta. Okay, so that's the first example. Second example is y is equal to minus 3 sine theta plus 4 cos theta. Example 3 is going to be y is equal to 4 sine theta minus 6 cos theta. And example 4 is going to be y is equal to minus 5 sine theta minus 12 cos theta. Okay, so can you calculate phi for each one of these? I'm not interested in r, it's just phi I'm interested in. And I'll give the answers in radians and degrees. Right, Tim, y plus not pi, not 2 pi for question 2. Right, okay. Let's just have a look at question 2. What we've got, this is x and this is y. So we've got 4 in the y direction and minus 3 in the x direction. So let's do this in blue, shall we? So I've got a line that's looking like that, okay, and the angle that I'm looking for is obviously greater than 90 and less than 180, but it's this angle here, isn't it? And when you do the calculation, let me just do it so I remind myself. So if you do it on your calculator, you do the arctan. It's question 2 we're doing, isn't it? So it's 4 divided by minus 3, and that is equal to minus 9.2. So let's just think about what it's done. I'll do this in green. So what it's calculated is, we've said 4 divided by minus 3. What it's calculated is minus 4 divided by 3. So it's said minus 4 and 3. So what it's calculated is that value there, isn't it? Which means that with this angle here, the green angle, is the same as the dotted angle, isn't it? Because those are two straight lines. So to get the thing that we need is we've got to add pi to the angle that we've got, the angle that the calculator gives us. So the calculator gives us minus 0.927, okay, and we have to add pi to that to get round to where we need to be. Is that all right? And that's why I'm saying draw yourself a little sketch, because you can see what it's doing. So let me just say again, what we've got is 4, what colour have I got? We've got 4 in y and minus 3x, which are those two values there. So the angle we're looking for is the blue one here. Okay, when you do the calculation, it can't tell the difference between 4 divided by minus 3 and minus 4 divided by 3. Okay, so it calculates this green angle here. Now you can see the way I've drawn that the green angle here is equal to this dotted angle here. So we either want pi minus that angle, unless it's a negative value, in which case we just take that value and we add pi to it to bring us round to the blue line there. Okay, so if you make both values for arctan positive, then you will get a Q1 every time. Yes, that's right, Philip. So if the A value and the B value are both positive, you will always be in that first quadrant. Okay, and what the calculator is calculating is it's calculating a value of theta, let's not do it in red, theta, which is greater than or equal to minus pi and less than or equal to pi. So it's in that range there, and we sometimes want that range, and sometimes we want 0 is less than or equal to pi, oops, not pi, theta, and less than or equal to 2 pi. Could I go through 3 and 4 as well? Of course I can. Right, so let me get rid of this little lot. Boing. Right, good. So now we'll do 3. So in the case of 3, we've got y is equal to minus 6, so that's there, and x is equal to 4, which is, what about there? So we've got an angle here, which is, that's 6, so this is a bit bigger than 45, isn't it? If this was 4, so this is 4, and this is minus 6. So this angle here, if this was 4 and 4, that would be 45 degrees, but that's gone down a bit, so this is greater than 45. Okay, so that's 50 degrees or something, I don't know. And if you put that into your calculator, you're going to get the minus value, I think. So arctan, of, we're doing 3, isn't it? So it's minus 6 divided by 4 equals minus 9.8. Okay, so that's nearly minus 60. So this angle here is minus 0.9, oops, 0.982, so 98 will do, and times recall A equals, which is minus 56 degrees. Okay, now that by itself might be adequate, but if the question said give the value between 0 and 2 pi, then what I'd actually need to give you, what you need to give as an answer, is that angle there, isn't it? Okay, which means that all we've got to do to this is to add 2 pi. Minus 9.8. Yes, I did get minus 9.8. What did you get? What did I do to get minus 9.8 radians? Sorry, Tim, I'd missed that. So you go shift tan, that's the arctan, minus 6 divided by 4 equals, and that's minus 9.8, which is the, this angle here. I've got, okay, let's do this again so we're absolutely clear. Shift tan of -6 divided by 4 is equal to -9.827. Have you missed an 8? Can you just check that? Don't know if you can see my calculator. Yeah, okay, yeah, right. That's another thing we need to be careful of. You know that sine, sorry, you know that tangent, tan, is equal to sine over cos. You know that, but what I'm saying is we need this value here, which is next to the cos, and this value here, which is next to the sine. So don't get confused by that, because this is actually 6 sine phi. It's not even 6, it's r sine phi cos theta, and this is r cos phi sine theta. Okay, so the 4 there is r cos phi, the -6 there is r sine phi. So tan is sine, which is the -6, over cos, the r's will cancel of course, so that gives me the -6 over 4. Be careful of that, because it's that's like a little bit of knowledge being a dangerous thing, because you think, cos sine, I know how tan works, and then you get it wrong. Okay, so let's take those away. Right, so are we okay with question 3 then? Philip, what did you say? If you remove the negatives, how would you get the answer? Yeah, don't remove the negatives. That's exactly what you don't do. Sorry, I should have picked that up when you said if you remove the negatives. The reason you don't remove the negatives is because you'll get the wrong answer here. If in this question 3, for instance, we've got -6 over 4, and the calculator will give you this negative angle here. If you put positive values in, you'd get a line, let's do it in green, you'd get a line up here, wouldn't you? Yucks, I didn't want to do that. I want a pen that's green. Oh yeah. Sorry, using the wrong pointer. So you'd get a line like that, where that angle there is 0.98. 0.98. So if you just remove the signs, you'd calculate this angle here, and I think that's a bit confusing, to be honest. So keep the negatives in, but just find out where your angle is going to. Right, okay, so shall I do 4 now? So let's have the lasso, take all that out, delete that. Okay, so with 4, let's start again with our axes. We've got -12 in the y direction, so that's down here, that's -12, so -5 in the x direction there, so we've got an angle down like that, haven't we? Okay, so we can now say that the angle we're expecting is greater than, let's say, 180 and less than 270. So it's in that quadrant there, but when we put this into the calculator, we know that it's going to cancel the 2 negatives out, don't we? So we know it's actually going to calculate that line there, where this is 12 and this is 5. Oh, not -5, 5. So it's going to calculate that angle there, which is phi, and we want this angle here. So let me do that again. So it's going to calculate this angle here. Let me call it alpha for now. And what we want is the angle that goes from here all the way around to there. Okay, so the green angle is equal to, so that's phi is equal to alpha plus pi. You can see that alpha would take you from the axis to the line, but then we've got to add another 180 degrees to that, don't we? So you'd stick that into your calculator, it'll give you a value of what did I say? It's about 1, isn't it? It's going to be something like that in radians, or 60 degrees ish, something of that order. Let's do it. So it's 12, so arctan of 12 divided by 5 equals, yeah, 1.17, 1.18. So this is 1.18 radians plus pi, and that will equal plus shift pi equals 4.3. Or 247 degrees. Are we angled it out? Have we had enough? Are we dead on our feet? Yeah, okay. This is still being recorded, and I'll keep all of this recording in, and when I post this. Dead describes it as well. All right. The thing is, Philip, you've got a brain the size of a planet, so I expect you to be able to assimilate this at some point and get it all right on the exam. Okay? No pressure, you understand? Just all right on the exam. Yeah, okay. I would be really pleased if you walk away with 85%. I wouldn't even grizzle if it was 81%. I'd let you get away with that extra 4%. So as long as you get away with 81%, we can remain friends. Less than that, though. Yeah. Okay. Are we all done then? Anybody else got a question? I don't think so. So shall I pull the plug? Right, I'm going to stop the recording. That's our last minute ism, Jack, if you don't mind me saying so. Question 2 on simultaneous equations. That was on the tutorial, you mean? Yeah, okay, let me find that. So that's question 1. Oh, that's not what you wanted. You meant this question 2, didn't you? Okay, so let's just slide that out of the way. Calculate pairs of intersections between these two lines. Is that the one, Jack? Is that what you want? Yeah. And do you care whether it's A, B, or C, or D, or whatever? A, B, C, or D? No, they're pretty much the same, aren't they? So A looks like the most complicated value. No, not really. Okay, so I'm going to go for A because it looks like the most complicated value. So let's erase all of that stuff. So we have two equations which are y is equal to 3x squared minus 2x minus 5 and y is equal to 2x plus 5. Now because these are both equal to y, we can set them equal to each other. So 3x squared minus 2x minus 5 is equal to 2x plus 5. So now what I'd like to do is to move everything onto the left hand side of the equation. So I've got 2x here. When I move it to the left hand side of the equation it becomes minus 2x. So I'm going to end up with 3x squared minus 4x, and then I have plus 5 on the right hand side. When that moves to the left hand side it becomes minus 5, so I've got minus 10 is equal to 0. So let's try and factorise that. We've got 3x and we've got x, so those multiplied together will give us the 3x squared that we've got there. Then the factors of 10 are 1 and 10, 2 and 5 and nothing else. We've got 3 times 5, which is 15, minus 2, that doesn't give us 4. We've got 2 times 3 is 6, minus 5, that doesn't give us 4 either. There's no obvious factorisation for this equation, so I'm going to use the quadratic equation. So let's just get rid of this little lot. So what we're going to say is that x is equal to minus b, b is minus 4, so that's 4, plus or minus the square root of b squared, which is 16, minus 4 times a, which is 3, times c, which is minus 10. And that's all over 2a, a is 3, so that's all over 6. So let's move that up a bit. 4 times 3 is 12. 12 times 10 is 120. That's minus, so that's going to be plus 120, plus 16, so that's 136. So x is equal to 4 plus or minus the square root of 136 divided by 6. 136 isn't a square, so I'm going to do this on a calculator. So I'll do the negative version first. So x is equal to minus 1.28 or 2.61. What I'm going to do now is to put those two values of x into 2x plus 5. So when x equals minus 1.28, y is equal to, so y is equal to 2.44. And when x is equal to 2.61, again we're going into this equation, 2 times 2.61 is 5.22 plus 5, so y is equal to 10.22. Now, as a sanity check, I'm going to put both of these values into the quadratic, which is there. So we're going to get 3 times minus 1.28 squared minus 2 times minus 1.28 minus 5, which is 2.44. And now we're going to put the 2.61 into the equation, so that's 3 times 2.61 squared minus 2 times 2.61 minus 5, which is 10.22. So that means we can write the two answers as polar coordinates, which is minus 1.28 in the x, comma 2.44 in the y direction. So that's the first answer we give, and then the second answer is going to be 2.61 and 10.22. Right, for the next example, let's just move that up. We're going to do y is equal to 3x over 2 plus 3, and 4y is equal to minus 7x squared over 2 plus 27x minus 16. I'm going to call that equation 1, and this one I'll call equation 2. Now, normally what I would do is I'd multiply equation 1 by 4, so I've got 4y in the first equation and 4y in the second equation. But in this case I've got minus 7 over 2x squared. So what I'm going to do is I'm going to multiply equation 1 by 8, and I'm going to multiply equation 2 by 2. That will give me 8y on the left hand side of both equations. So multiplying equation 1 by 8, I'm going to get 8y is equal to 8 times 3 is 24 divided by 2 is 12, so that's 12x, and 3 times 8 is 24. And then multiplying equation 2 by 2, I'm going to get 8y is equal to minus 7x squared plus 27, 40, 54 x minus 32. So now we've got 8y on the left hand side of both equations, so we can set the equations equal to each other. So minus 7x squared plus 54x minus 32 is equal to 12x plus 24. Okay, so what we'll do now is we'll move everything onto the left hand side. So we're going to get minus 7x squared. We've got 54x here and 12x here, so that's going to be 42, so that's plus 42x. And we've got minus 32 here and plus 24 here, so that will become minus 24 when you move it over. So that's going to be minus 56 is equal to 0. Okay, now the obvious thing to do now is to divide through by 7, so minus x squared plus 6x minus 8 is equal to 0. Now let's see if we can factorise this. So we'll have a minus outside a pair of brackets. We'll have an x in one and an x in the other. And we'll look at the factors of 8. So we've got 1 and 8 and 2 and 4. Okay, we can see how this could work in one bracket and a 4 in the other bracket. And they both need to be minus because of the minus that we've got outside here. So as a sanity check, let's just expand this. We've got x times x, which will give us x squared. We've got x times minus 4, which will give us minus 4x. Then we've got minus 2 times x, which will give us minus 2x. And then we've got minus 2 times minus 4, which will give us plus 8. Okay, but all of that is inside a bracket with a minus outside. So if I now bring the minus inside, I've got minus x squared plus 4 minus 2, so that's going to be 6x minus 8. Okay, so that is the correct factorization. So let's just remove those. So if x minus 2 equals 0, x equals 2 is one root, and x minus 4 equals 0, so x equals 4 is another root. X equals 2, that's going to be 3 plus 3, so y is equal to 6. And when x is equal to 4, I'll put that in here. So 3 times 4 is 12, divided by 2 is 6, plus 3 is 9. So y is equal to 9. So as a sanity check, we'll put these values into the second equation. So when x is 4, 4 squared is 16, 16 divided by 2 is 8, 8 times 7 is 56, and that's minus, so we've got minus 56. 4 times 27 is 5408, 108 minus 56 is 52, 52 minus 16 is 36, and 36 divided by 4 is 9. Okay, so the sanity check works. So that means we can write our answers as a bracket with 2, 6, which is the x and y value, and the other point of intersection is going to be 4, 9 brackets. And that's our answer.